Last time we talked a little bit about data and types. Data and types are all well and good, but you can't do much with them. Today we're going to introduce operators, which allow you to combine pieces of data and actually do computation. So just as an analogy, operators are a little bit like glue. They're what helps you stick together the data you already have into something much more useful. So just to give you an idea of what operators are, you already know some operators. One of them is plus, which I'm sure you remember from algebra, hopefully. Then we also have other arithmetic operators like minus. Then we should note that some of the arithmetic operators don't act quite like you think they should. So for example, what's 5 divided by 2? 2.5, right? Well, when we put it into C0, we'll get 2 out. And the reason for that is we can only have whole numbers in C0. We can only have integers. So when we divide 5 by 2, C0 needs to figure out the most logical integer to give us. And the way that it does that is just by doing the division and then rounding down the result. If we do negative 5 divided by 2, we get the same thing except negative. So we always round towards 0. We also have another type of operator that you're probably familiar with, comparison operators. So for example, we can ask C0 if 5 is less than or equal to 6. We get true, and keep in mind that this operator takes in two integers and gives us back a boolean. Some other comparisons, which I'm sure you've seen before but might look a little bit different, are equality, or double equals, which will tell us if two numbers are the same, and inequality, or not equals, which will tell us if two numbers are not the same. So actually, let's try this. So 7 is not equal to 7 is false because 7 equals 7 is true. Okay, so now let's look at some operators which you may not have seen before. We have a class of operators called the Boolean operators, and as you might have guessed, they act on the Boolean values that we told you about in the previous lesson. So for example, we have one called OR, and we can ask it what true or false is. So OR, you'll see, is represented by two vertical bars, and true or false is true. The reason for that is that OR is very related to the English language definition of OR. So OR takes two inputs, which you'll see are both Booleans, and the output will be true if the first input or the second input is true. So because of that, this statement is also true, but the following is not, because neither the first nor the second input is true. Some other Boolean operators that we have are AND, which works similarly to OR, except that it requires the first and second inputs to be true, and NOT, or BANG, as some people call it. So not true is false, and not false will be true. A third class of operator, which is a little bit weird, a fourth class of operator, which may seem a little bit strange to you, is something called bitwise operators. They look like the Boolean operators, but they're in fact very different. So let's look at 7 and 8, for example. This gives us 0. How is that possible? So one thing to look at is that the binary representation of 7 is actually 0, 1, 1, 1, while the binary representation of 8 is 1, 0, 0, 0. Now notice that if we stack those two numbers up on top of each other, there would be no column in which we have two ones. So what bitwise AND does is it looks at every column and performs a logical AND, a double AND sign, as if ones were trues and zeros were falses. So when we line up the 7 above the 8, there's no column that has two ones or two trues, so our result is all zeros or falses. That'll take a little bit to get used to, but we'll talk a little bit more about it in the notes. One more thing to point out is that we have order of operations. Order of operations works the same way that you remembered it working in math class, except with a few additions because we now have no operators. So for example, if we check if 7 times 6 double equals 42, we'll get true instead of crashing. And the reason for this is C0 chooses to do 7 times 6 before it does 42. If we do it in the other direction, the same thing will happen. That's because C0 always looks and does arithmetic operations like times before it does comparisons like double equals or equality. So that's all for now. We'll talk a little bit more about it in the notes, and then after that, we'll move on to discuss variables.